All right. Moving on in the world to section 4.1. Chapter 4 is all about fractions. So 4.1 is sort of an intro chapter to fractions and mixed numbers. This first video, we're just going to do some intro things and talk through some standard properties for fractions. So, what the heck is a fraction? What does it look like? So our form, right, is something like a over b. You essentially use a division bar. A fraction looks like division because it really is division. Essentially, it's the number on top divided by the number on the bottom, but you're not necessarily looking to do like a long division and get a decimal type answer. We'll do some long division with decimals in chapter 5, the decimals chapter, and we'll do a little bit of long division here actually. So this essentially looks kind of like long division or it looks like division because it is division. But also at the same time, fraction itself is just a number on its own. And so in general, what we're doing when we're working with fractions is we need some sort of way to express numbers that are not necessarily whole numbers. We need some sort of way to express numbers that fall between the cracks of the whole numbers, right? So halfway between 3 and 4 would be 3.5. Right? And so we need a fraction. We need some other way to sort of write that. We can't just sort of write it as a whole number because it's not quite 3 and it's not quite 4. The vocabulary here, the number on top is what we call the numerator. And the number on the bottom is what we call the denominator. And I'll actually define them in sort of reverse order. So our denominator is how many pieces you're sort of breaking your whole value into. So it's how many pieces make up a whole. So I said half, right? 1/2 is when you break into 2 pieces, 2 equal-sized pieces. If you do 1/4, that's the same thing as 1/4. You're breaking into 4 pieces. If you do 1/10, right, you're breaking into 10 pieces, and so on and so forth. The numerator, your number on top, is how many of those smaller pieces you have. So the way I kind of think of fractions is, let's sort of put an example down, a couple of examples, right? So let's say I've got 3 over 8. Usually we would say 3/8. Oops, I misspelled 8. We'll just sort of push through it. 3/8, off to a good start. So the idea here, right, is you have 3 pieces where 8 pieces equals 1 whole value. If you do the kind of classic like visualization here is this sort of pizza kind of visual, right? If you sort of take a pizza and so you're working with eighths, which means you take your pizza and you're cutting it into 8 equal-sized pieces. This is not a perfect drawing, so we'll just kind of work with what we've got. So this is 8 pieces to make up 1 whole pizza, and so 3/8, right, what we're working with here is 3 of these 8 pieces. So you can see we're not quite covering a half of the pizza. We have a little bit less than that. In fact, exactly what we have is 3/8 of the pizza. Let's sort of quickly visualize another one, right? Maybe I've got something like, I don't know, right? 5/6, right? 5 over 6. Right. So our visual here, if we sort of take a pizza, we're going to try to cut it into 6 equal-sized slices. I'm well aware, again, these are not exactly equal, but humor me. So our fraction represents 5 of these 6, right? So we're sort of less than 1 whole. We're not quite getting all the way there, right? So we can kind of think of our fractions in terms of these pizza pieces, but we can also just sort of think of them as numbers, right? This is really sort of, in some sense, you're talking about you have 3 of a thing. You can almost think of it like units or something, right? Instead of 3 feet or 3 inches or 3 yards, you have 3/8. So the thing you have is an eighth, right? So the bottom number in your fraction, your denominator, is really the type of fraction you're working with. And your numerator is how many of those things do you have. That kind of conception is going to be really useful when we actually start to do arithmetic with these, if we're trying to sort of add, subtract, multiply, and divide them all together. One of the things that's going to happen right before we can do any kind of addition or subtraction of numbers, we have to make sure we have the same types of numbers. So I can't necessarily add 3/8 to 5/6 by themselves, because the result is going to be, who knows, right? We'll have to sort of figure it out. You wouldn't take a 6 and turn it into an 8. You wouldn't take an 8 and turn it into a 6. So you need to find some sort of middle ground. That's getting ahead of ourselves. A couple just sort of general properties before we look at some other stuff. So a couple things. So one thing that we can't do, so if we have like a over b, b is not allowed to be 0, right? So we can't have 0 as a denominator, and that's because we're not allowed to divide by 0. So we can use more or less any number we want in theory, right? We're working with whole numbers. You can do fractions of fractions. That's, again, stuff we'll sort of be looking at later on in chapter 4. That's sort of getting ahead of ourselves a little bit. In general, you're going to be sort of looking for whole numbers here. And any number will do. Positive, negative is fine. You just can't have a 0 in the bottom. If you divide by 0, it's going to sort of wreck your thing. And so what you would say is we would sort of call this undefined, or what you can write on a test or a quiz is DNE, which means does not exist. So dividing by 0 is sort of just one of these math rules that we have that's surprisingly complicated. It doesn't necessarily give you a 0, which I think is what you might sort of guess. It makes a pretty raucous kind of situation. Number 2, so one thing that is okay is if I have a 0 in the numerator, I'm just going to get a 0. So 0 in the numerator just makes the whole thing 0, right? And this conceptually kind of makes a little bit more sense, because you're saying, okay, I'm working with thirds, let's say, and I have 0 on top. So I have 0 thirds. Means I just have nothing. I just have 0 everything, right? 0 thirds just is 0. I don't have any of these pieces, which means I just don't have any value, and that's that. Question number 3. If you end up with a over a, so if you end up with 3 over 3, right, 10 over 10, 7 out of 7, so what that means is you've got a whole that's broken up into 7 pieces, let's say, and then you have 7 of those pieces. Well, 7 out of 7 is going to get you back to 1 whole, right? So you're going to have 1 whole if you have 3 out of 3, 5 out of 5, 10 out of 10, 50 out of 50, right? You're thinking of maybe quiz course or test course or something there, right? It means 100%. It means you have 1 whole value. So you can take, if you get the same values on the top and the bottom, they essentially become just whole value 1. You could think of these sort of things as reducing down. That's what we're going to be sort of doing a little bit later. The other property with 1s is if I have a 1 in my denominator, that means I just get the numerator value. So if I have 6 over 1, right, 1 piece makes a whole, and then I have 6 of those pieces, so that means I have 6 whole values. 6 whole is just going to be 6, right? So anything over 1 just becomes the whole number. This is actually a property that we're going to maybe use a little bit going the other direction. So sometimes we'll kind of reverse this, and we'll go from something like 5 into 5 over 1, right? So you can sort of run this the other direction if you want. In theory, any of these would sort of do that, right? You can kind of always take, you know, whole number 1 and turn it into 6 over 6 or 7 over 7, right? You can also reverse this, right? If I have 1, I could sort of flip it and call this 5 over 5. Right, so these properties allow us to sort of rewrite fractions, but if we also kind of conceptualize and reverse them, it allows us to sometimes take some special whole numbers and turn them into fractions. This is all stuff that will be useful kind of later on as we start to do arithmetic operations with our fractions. And that's the idea.